intercept form. So any line can be represented in slope-intercept form as y is equal to mx plus b, where this m right over here, that is the slope of the line, and this b over here, this is the y-intercept. Y-intercept of the line. Let me draw a quick line here just so that we can visualize that a little bit. So that is my y-axis, and then that is my x-axis. My x-axis, and let me draw a line. And since our line here has a negative slope, I'll draw a downward sloping line. So let's say our line looks something like that. Let's say it looks something like that. So hopefully we're a little familiar with the slope already. The slope essentially tells us, look, start at some point on the line and go to some other point of the line, measure how much you have to move in the x direction, that is your run, and then measure how much you have to move in the y direction, that is your rise, and our slope is equal to rise over run. And you can see over here it would be downward sloping, because if you move in the positive x direction, we have to go down. If our run is positive, our rise here is negative. So this would be a negative over positive, give you a negative number. That makes sense because we're downward sloping. The more we go down in this situation, for every step we move to the right, the more downward sloping will be, the more of a negative slope.
Okay, so the way I see it is slope intercept form is y equals mx plus b. The slope is m and the intercept is b. That's why it's called slope intercept form. So then we need to define slope and intercept. Slope is m. I think slope equals y over x. Okay, b is the y-intercept. What's the y-intercept in this graph? The y-intercept is 0. Actually, the y-intercept, sorry, is up here. It's whatever this point is. The x-intercept is 0. So then we look at slope again, and slope is y over x, or what we call rise over run. The rise is y here minus y here. The run is x here minus x here. So the difference there is that if you were to plug it in, you would have y equals y over x times x plus b. Except y over x is 1 point, so it doesn't really make any sense. It would be y equals y plus b. So the slope is y1 or y2 minus y1 over x2 minus x1 plus b times x equals y. What is the slope of the line through 6, 9, and 7, 1? So it's y's over run, or 8 over 1, which equals 8. Oh. Negative 8. The slope of the line is 1 minus negative 4, or 5, so 1/2. Negative 7 minus 9 is negative 16, so negative 4. All right, I'll write it down. Y2, oh, it's Y1 let's try y, as long as it's consistent. So y2 is 9 minus 7. 9 minus negative 7 is 16. And 3 minus negative 1 is 4. So it's positive 4. So y2 is 3. 3 minus negative 2 equals 5. 9 minus 2 equals 7. So 5/7.
We've got the equation y plus 2 is equal to negative 2 times x minus 3. And what I want to do is figure out what is the slope of the line that this equation describes. And there's a couple of ways that you can approach it. What my brain wants to do is, well, I know a few forms where it's easy to pick out the slope. For example, if I can manipulate that equation to get be in the form y is equal to mx plus b, well then I know that this m here, the coefficient on the x term, well, that's going to be my slope, and b is going to be my y-intercept. We covered that in many other videos. Another option is to get into point slope form. So the general framework or the general template for point slope form is if I have an equation of the form y minus y1 is equal to m times x minus x1, well, then I immediately know that the line that this equation describes is going to have a slope of m, once again. And here, the y-intercept doesn't jump out at you. Let me make sure you can read this over here. The y-intercept doesn't jump out at you, but you know a point that is on this line. In particular, you know that the point x1, y1 is going to be on this line, x1, comma, y1. So let's look at our original example. So it might immediately jump out at you that this is actually in point slope form. You might say, well, okay, I see I have a minus x1, so x1 would be 3. I have my slope here, and that answers our question. Our slope would be negative 2. But here it says plus 2. I have to subtract.
So would y minus y1 equal the same as y2 minus y1? And it's yes if you do the same for y and x. So it's just up to you.
To y1. Well, you could just rewrite this. So it says, so you have y minus negative 2 is equal to negative 2 times x minus 3. And then you see it's exactly this point slope form right over here. So our slope right over there is negative 2. And then if I were to ask you, well, give me a point that sits on this line, you could say, all right, an x1 would be 3, and a y1 would be negative 2. This point sits on the line. It's not the y-intercept, but it's a point on the line, and we know the slope is negative 2. Now, another way to approach this is to just manipulate it so that we get into slope-intercept form. So let's do that. Let's manipulate it so we get into slope-intercept form. So the first thing my brain wants to do is distribute this negative 2. And if I do that, I get y plus 2 is equal to negative 2x, negative 2 times negative 3, plus 6. And then I can subtract 2 from both sides. And then I get y is equal to negative 2x plus 4. And so here I am in slope y-intercept form. And once again, I could say, all right, my m here, the coefficient on the x term, is my slope. So my slope is negative 2. Let's do
So when you solve this, one of the benefits is you can plug in things for x and y, right? So if you look at the coordinate, the way you plug in a coordinate, one is 0, 0. That's not that helpful. Parentheses 0, comma 0. That means x equals 0, y equals 0. So if you plug that in, you get the actual coordinates according to this formula of where on the line on the graph you could plug it in. So if x equals 0, y equals 4. And that's the x-intercept. Or sorry, that's the y-intercept. So at 0, 0, the y-intercept or 4 is always self-described.
Another example.
Let's plug in 1, 1. So you always start with x. I guess not, but minus 2 plus 4. And it won't work. Equals 2. So what you could do instead, so one thing you can always plug in is 0, 0, and that will give the y-intercept. If you plug in 1 then for x, you know that y equals 1 or minus 2 plus 4 equals 2. So 1, 2 is another coordinate. Now you have 2, and you can draw the line. You want to draw the line.
So here, this equation doesn't immediately go into either one of these forms. So let's manipulate it. And if it's in either one of them, I like to get into slope y-intercept form. It's a little bit easier for my brain to understand. So let's do that. So let us collect, well, let's get the x's, let's just isolate the y on the right-hand side since the 2y is already there. So let's add 3 to both sides. I'm just trying to get rid of this negative 3. So if we add 3 to both sides, on the left-hand side, we have negative 4x plus 10 is equal to 2y. These cancel out. That was the whole point. And now to solve for y, we just have to divide both sides by 2. So if we divide everything...
So if you wonder, why can he add 3? Right. If you want to balance an equation, my sense is as long as you do the same thing on the left side, you can do the same thing on the right side. Right? 1 equals 1. 4 equals 4.
By 2, we get negative 2x plus 5 is equal to y. So this is in slope-intercept form. I just have the y on the right-hand side instead of the left-hand side. But you have y is equal to mx plus b. And so our m is the coefficient on the x term right over here. So our slope is once again is negative 2. And here our y-intercept is 5 in case we wanted to know it. Let's do one more example. One more example. All right. So once again, this is in neither slope-intercept or point-slope form to begin with. So let's just try to get it to slope-intercept form. And like always, pause the video and see if you can figure it out yourself. All right. So let's get all the y's on the left-hand side isolated.
Okay, so we want to get this to...
And the x's on the right-hand side. So let me get...
So it's minus 3x plus 5y equals 2x plus 3y. Okay, so that's point slope form, I guess, which is y minus y1 equals m x minus x1. So we want to get this, we want to get the y's on the right side, on the left side, and the x's on the right side, and then factor for m. So how do we get minus 3x plus 5y? We want the x on the right side. So if we add 3x to both, then the minus 3x crosses out. We have 5y equals 5x plus 3y. Then we subtract by 3y. We have 2y equals 5x. I don't know.
Rid of this negative 3x. So I'm going to add 3x to both sides. And let's get rid of this 3y right over here. So let's subtract 3y from both sides. You could view this, I'm doing 2 steps at once. But once again, I'm trying to get rid of this 3x. So I'm trying to get rid of this negative 3x. So I add 3x to the left, but I have to do it to the right if I want to maintain the equality. And if I want to get rid of this 3y, well, I subtract 3y from here.
So y equals 2 and 1/2 x.
Here, but I have to do it on the left-hand side if I want to maintain the equality. So what do I get? That cancels out. 5y minus 3y is 2y is equal to 2x plus 3x is 5x. And then these two characters cancel out. And so if I want to solve for y, I just divide both sides by 2, and I get y is equal to 5 halves x. And I'm done. And you might say, wait, this doesn't look exactly like